If you're running a home lab, chances are that you probably know how to shut down all your servers remotely, but wouldn't it be cool if you could also turn them back on again? And I mean, not by just pressing a simple button, no, also completely from remote. Hey everybody, this is Christian, and in this video I want to talk about Wake On LAN. And this is a pretty cool technology that we use in professional IT to turn on remote machines, computers or servers over the network even when they are entirely powered off. This is really nice. I've recently set up this in my home lab because I usually shut down all my big servers every night just to save some power. And when I'm about to start a new workday, I can simply press a button on my phone to turn the machine on. And this also works when I'm on vacation, so I can simply connect with a VPN to my home network. Let's have a look how that works. But before we start, I just want to spend 1 or 2 minutes to just say thank you so much for your support. Some of you might know that I recently made a video about why I almost quit YouTube and that I took a few weeks off. And the overall response to that video was so positive. I got so many comments, likes, even from other big YouTube creators that are supporting me. Also, I even got many donations from some of you guys or signups on my Patreon page, so thank you so much for that. Some of you might have noticed that I recently shut down the YouTube membership program because I wanted to streamline it all through one single platform, which is now Patreon. And I introduced a couple of new benefits just to offer you something in return, like early access to all of my videos that I also upload now on Patreon, where you can watch them without any ads or without interruptions, or you get access to an exclusive member chat on my Discord. Many other cool things that you can check out there, but just to keep in mind, don't feel pushed or forced by me to sign up or send donations to me. You guys know I still have my main job as a professional IT guy, so I'm totally fine. But if you want to show your appreciation for all of the free tutorials and content that I'm creating here, Patreon is now the right place to do that, so you will find a link in the description of all of my new videos from now on. But that's about it. Let's go back to topic and talk about Wake On LAN. Okay, so let's imagine you have a small home network where you have a couple of machines and servers represented by the network cards on the left side, and you, from your client, you want to turn on one of these machines over the network completely from remote. How do you implement Wake On LAN to actually do this? So the first thing to know about Wake On LAN is that you need to send a small instruction over the computer's network to turn on these machines. And this is done by sending a so-called magic packet to the particular server that you want to turn on. So the magic packet is a short sequence that consists of a 6-byte header of the number 255. So that's in hexadecimal FF:FF:, and so on. And then followed by the target's device MAC address 16 times. And yeah, that's actually the whole payload of this magic packet. And this is typically sent as a UDP broadcast packet to all of the devices within that network so that it's picked up by every machine. And when the machine that has the exact MAC address like you described in the magic packet receives this Ethernet frame, it will trigger the whole machine or the whole computer to power on and start the boot sequence. One thing that is worth noting, I said typically it's sent as a UDP broadcast packet, but technically you could also encapsulate the magic packet in other protocols and other ways. So you could also send it as a unicast to one particular IP address or encapsulate it in a different protocol. So this is also possible. But mostly you will see a UDP packet that's sent out to all IP addresses within that network on port 9. Of course, it's important that the target device that you want to power on still listens for incoming network connections. So even when the whole device is powered off and yeah, it's not started or booted, it still needs to be in a somewhat low power active state. So at least the network card needs to be enabled to receive incoming network packets. But most likely all of the modern hardwares like mainboards with integrated network card interfaces or even PCIe network cards most likely all support Wake On LAN. So I've rarely seen a device that does not have this feature somehow, but it is usually not enabled by default. So this is one thing you firstly need to enable in the BIOS of your computer. It's usually found under the power management or power options section of your BIOS, but of course this is completely different depending on what type of manufacturer your mainboard is from. That's the first thing that you need to enable. The second is you also need to enable it in the operating system, because otherwise the hardware might support and receive those packets, but the operating system won't start the boot sequence. And this is also, of course, depending on what type of operating system you're using. If you're using Windows, the setting is usually located in the device manager settings of your network card interfaces. There should be a setting somewhere where it says Wake On LAN. But of course, I know most of you guys don't use Windows servers somewhere in your home lab. You most likely will use a Linux-based operating system. And Linux is a bit different, of course, but you can also enable Wake On LAN very easily on any type of Linux operating system, because it's a kernel feature that should be supported on all distributions. To demonstrate how to enable Wake On LAN on a Linux-based operating system, let me just connect to my Proxmox server to show you around. And as you might know, Proxmox is a Debian-based Linux distro, so that should also work on any other Linux operating system as well. And the first thing that we need to find out is the name of the network card, because depending on what type of hardware you have, or if you're using different network cards, the names might be different. And you can inspect them by using an IPADDR show command. So this will just list out all the network card interfaces with the MAC addresses and IP addresses attached to them. And the first entry is the LO entry. This is just the local loopback interface. This is nothing physically, and you should not worry about it. The next entry is the integrated network card on the main board. So this is the ENP4S0. As I said, the name might be different on your system. But as this is the integrated network card, this should also support Wake On LAN. But I also have connected 2 other ports here to the system. So you can see this is plugged into the first PCIe slot. And this is the 10 gigabit network card that has 2 ports here. And you might also find any other virtual network cards, like virtual bridges in here, any Docker interfaces, or any other hardware devices you have plugged in to your computer. And to inspect some of the details of these network cards and to find out if they support Wake On LAN and if it's enabled or not, we will use a second command line tool, which is called the EDH tool. There you can inspect all of the details of these network cards. For example, if I just enter the EDH tool on the ENP4S0 interface, you can see some of the details what this integrated network chip supports. And the interesting section for us is if it supports Wake On LAN. You can also grab for these 2 settings, and as you can see, it supports Wake On LAN, and then it is a pretty strange name in here, which is by every character here represents a specific feature that could be enabled in the Wake On LAN settings. So I don't want to go into too much of the details here. The important setting for us is the G parameter. So if this is present here, then your network card supports Wake On LAN. And you can also inspect the current setting. As you can see, Wake On is currently disabled, so the D stands for disabled. If your network card does not support Wake On LAN, so for example, let's execute the same command on one of the 10 gigabit ports, you can see that supports Wake On is just represented by a D, and this means you cannot enable Wake On LAN. As I said, most likely all integrated network cards on your main boards or usual Ethernet, 1 gigabit Ethernet cards, they most likely all support Wake On LAN. And to enable Wake On LAN on your network card interface, you can use the same command, EDH tool, but with a -S parameter on your interface. And then you can simply type in WOL for Wake On LAN and set the specific setting. D for disabled. Let's change it to one of these options that this network card supports. G is the parameter that we're going to use. So this enables Wake On LAN. And when I execute the command again to check the current setting, you can see no Wake On LAN is enabled. There's one thing I forgot, because we also need to make this setting persistent in the configuration, because usually when you reboot your computer, this setting is reset to the default. And that's of course not what we want. So to make this setting persistent, we need to open the network card configuration file, which is located in the etc network directory and called interfaces. You can see this is the main configuration of all the network card interfaces, and that configures static IP addresses and bridges and all of this stuff. And what we can do here is we can scroll to the end and insert a command, a post up command. So this will be executed after the network card has been initialized. And then we can simply just use the same command that we were using manually the ETH tool, and this will change the setting on the ENP4S0 interface and make the Wake On LAN setting active. So just save this and let's check if the setting is there after the reboot. Okay, so the server is online again. Let's check if the setting is still persistent. And you can see, yep, Wake On LAN is active. So we can now wake up this computer even when it's powered off. So what we need to do that is we need to note the MAC address of this network card interface where we want to send the magic packet to, of course. And you can also simply do this by executing the IP-AEDDR command. Again, you can see this is the network card interface, and it currently doesn't have an IP address because it's a bridge interface. But what you still can inspect here is the MAC address of the network card. So this is always unique. Every network card in the world has its own MAC address, except for virtual machines, but you usually don't wake up a virtual machine with the magic packets. So this is the MAC address that you need to write down. Okay, so let's shut down this machine, and then we can try to wake it up over the network. Okay, so the server is shut down. You can see I still have opened my terminal on the Mac because the way how you create this magic packet is very simple. I don't know if that's possible in Windows PowerShell as well, but it should actually work. So I'm going to install the tool Wake On LAN on my Mac. This is probably the easiest command to use. And there you can get a couple of different options, what you can specify. So you can specify a destination IP address, but by default, I said most likely you will use a broadcast. So this is always set by default to the broadcast address. And the destination port is 9 by default, so that's also fine. What you need to type in is the Wake On LAN and then the MAC address. But what I also want to do is I want to show you what actually happens when you execute this Wake On LAN. So how does the magic packet look? And this can be easily done by executing a packet capture on my Mac. So I will use the tcpdump command and I will display some of the details of the packets and capture any interface on my computer. And I'm looking for two specific protocols. I'm looking for the Ether protocol, but I'm also looking for the UDP traffic on port 9, because this is the protocol where the magic packet is encapsulated in. So let's run this command, and then we should be able to capture the Wake On LAN packet. So let's execute the Wake On LAN packet, and I'm entering on the MAC address of my server's network card. And when I execute this, you can see that the computer immediately starts to power on. So this is the raw content of the network packet. If you take a closer look, you can see this packet is encapsulated in an IP packet using the UDP protocol. And the payload actually starts here at the FF, and so on. Remember, this is the first part of the magic packet, the value 255, followed by the MAC address of the computer, repeated 16 times. So this is how you can inspect the magic packet on the network card. And if you configured everything correctly, it should also power on your remote computer. Just to let you know, this is of course not the only way to generate this magic packet. You can also find apps for your phone. You can find desktop applications for Windows, Mac OS. So there are so many programs that just generate this very simple packet because it's not really a complicated thing. And this is how you can trigger your powered off server or computer from within your network. And yeah, I just said within your network, because this is one of the problems you might run into if you have a more complex network architecture. Like in my home lab, for example, I have not just one network, I have multiple networks. And when you separated your network, maybe because you wanted to protect your servers from the rest of your network, and your client is located in a different network, how do you send this magic packet from one network to another? This is a more complicated thing. So that's why I also wanted to present you a way how I've implemented this in my network, because as I said, my network is also separated. And just assume you have a client that is located in one network. This is the 192.168.0.0 with a 24 subnet mask, and you have a different network, so with a different router or different gateway that's located in the 192.168.10.0.24 network. And this is where your server is located. So how do you get this magic packet from one network to another? Because if you send out a magic packet from your client with a broadcast address, the first gateway will spread it across the entire network, but it won't send it to the second network. So this is why I'm using a different approach than just sending the magic packet directly from my phone with an app or from my computer. And this is where I'm using another trick. I'm using a different machine, a small computer that is located in the second network as well, because I've also installed a small HomeAssistant computer. So this is running on a Zima board that is a very power efficient machine. And this is what I've turned on 24/7, because usually all my HomeAssistant things like my IoT devices and my DNS server, they need to be 24/7 available. So there's no reason for me to shut down this small computer. It can run forever. And because this is also located in the same network as my big machine, which is powered off, I can simply wake this server on from my HomeAssistant, and my client can simply connect to the HomeAssistant by using a different protocol like HTTPS, which is a secured connection. Then it will send out this magic packet from this particular machine. And this is even working when HomeAssistant is deployed in Docker. I will show you exactly how I've configured it to make it work. And of course, this is also an easy solution if you want to use a VPN connection, because you could use a remote client, connect with a VPN directly to your HomeAssistant, and the magic packet can also be sent out from there. No matter what's your VPN network or what's the IP address, if the HomeAssistant is located in the same network as the server, it's fairly straightforward to use a broadcast magic packet. So this is my HomeAssistant installation. I've recently shown that in another tutorial, so if you don't know what HomeAssistant is and how to set up this software, I've made a tutorial about it. Don't worry, I will put the video link in the description down below so you can easily check it out and deploy HomeAssistant. It's a pretty great software to manage IoT devices, but you can do so many other cool things in your home network. And this is one of the things that I've recently discovered, because you could also create a button that will send out a Wake On LAN packet to wake up another computer. So this is a button that I've created on my HomeAssistant dashboard. Let me quickly show you how that works. And so let's connect to my server where I've deployed HomeAssistant. So this is the small Zima board computer. And as you can see, this is where HomeAssistant is deployed in a Docker container. So this is this one here. So let's open the project folder where I have stored the HomeAssistant configuration files, because this is the first thing that you need to do. You need to open the config directory and go into the configuration.yaml file and add a new section in here. And the section is just called Wake On LAN : you don't need to add any content in here. It's very straightforward. And the second thing is that you need to create a new switch to create a button later in the dashboard. The platform that you need to use is Wake On LAN. And then you need to type in the MAC address of the device. And then you can also give it a name. In my example, I'm just setting it to the name of the server, which is my Proxmox Production Server 2. Okay, so this is everything you need. Once you've made these configuration entries, you need to go into the developer tools and reload the YAML configuration. And then when you go into the settings, devices and services, you should see in the entity section a new switch with the name that you have defined. So this is what you can use. And yeah, to create a button in the dashboard, like here in the server dashboard, you can simply edit it and add a new card. Then maybe select a simple button, because yeah, you can just use a button to turn on the server. Select the particular entity, like in my case, this is the switch PRX Pro 2. When you go to the tab action, you need to call a service, and the service will be Wake On LAN send magic packet. And this is where you can just specify the MAC address again. You could also change the broadcast IP address. Remember, by default, it's sent out as a broadcast to all network devices. You could also set it to a unicast. And you could also change the UDP port from the default, which is port 9, to anything else, depending on what is your setup, what you need. But again, if the HomeAssistant computer is in the same network as the server you want to wake up, then you can simply just leave it by default and use the MAC address with a broadcast. That should be pretty straightforward. Click on save, and then you have a button. And yeah, this of course I could also just easily open from my phone. And as I can see, when I click this button, it will boot up my server. And yeah, this is everything you need to know to implement Wake On LAN in your network. As I said, it's actually pretty straightforward. It's not a very complicated technology, but as soon as you have more than one network, it gets a bit more complicated. And if you want to have that very simple and accessible from anywhere in the world, then yeah, just deploy and use HomeAssistant to initiate the magic packet. This is, for me personally, the most easiest way to do that. I hope you enjoyed this video, and I hope you enjoyed that I'm back. Now I will create many more videos and tutorials for you guys. Again, thank you so much for your support. Thanks to all my supporters on Patreon. And yeah, let's have a chat on Discord about this. And thanks everybody for watching. I will catch you in the next video. Take care. Bye bye.